You changed the rubber washer, put the handle back on, and thought the problem was solved. But weeks later, the persistent drip is back. But there is a worse scenario than a rising water bill. You might be growing hidden rot inside your walls, even though none of your pipes have burst. We tend to treat plumbing like magic. You twist a knob, water appears. Twist it back, and it stops. But that shower handle is actually the steering wheel for a mechanical barricade engineered to hold back immense municipal water pressure. When those barricades fail, the actual broken components are completely hidden from sight, locked away behind the decorative plates on your shower wall. To stop a persistent drip or save your framing from quiet destruction, you have to look past the handle and diagnose the hidden anatomy of the valve itself. Getting to the root of a stubborn spout leak starts with stripping away the exterior hardware. Pulling off the handle and the wall plate reveals the raw valve stud mounted deep inside the wall. This animated cross-section shows the valve barricade. A rubber washer presses flush against a smooth metal ring, the seat, blocking water. Over years, friction creates microscopic divots in this brass seat. The scarred metal actively shreds new washers, letting high-pressure water force maritime through. You cannot fix this with a standard wrench or pliers. The damaged component sits too deep inside the pipe assembly to reach. You need a specialized tool called a seat wrench. It plunges straight down the center of the wall pipe to grip the scarred brass ring, so you can manually extract and replace it. Swapping out a torn washer without inspecting the brass seat underneath it guarantees the leak will return. True repair requires diagnosing and replacing the compromised metal foundation. That explains the spout drip, but what about the water that somehow escapes into your drywall? This cutaway reveals the secondary barricade on the outer stem, a hex-shaped packing nut, and underneath it, a thick rubbery gasket called the packing. Tightening the nut squashes the rubber packing outward, forming a watertight chokehold around the central rod. Constant rotational friction from turning the shower on and off grinds down this rubber material. When the seal shrinks, water stops flowing toward the spout. Instead, water reverses direction, escaping backward through the loosened gap behind the nut assembly. Because this escape route happens behind the decorative wall plate, you rarely see the water. It bypasses your tub completely and silently cascades down the unseen interior framing of your house. Fixing it requires pulling the stem entirely out. You forcefully wrap new packing material around the rod before screwing the nut back down to re-establish the squashed barricade. That mysterious wall rot rarely comes from a burst pipe. It is the result of a simple, hidden ring of compressed rubber, losing its grip against decades of water pressure. Once you have replaced the internal components, the final step is the slow reintroduction of the home's main water pressure to the newly assembled system. This plumbing blueprint shows a crucial preventative hack. Before turning on your repaired shower, open a completely separate faucet at the far end of the house. This flushes the entire system. If you skip this flush, the sudden rush of water will blast any pipe rust dislodged during your repair directly into your new fixture, permanently clogging the delicate aerator screens inside your shower head. Finally, you have to carefully tune the tension on your new packing nut. If you over-tighten the newly installed packing material, your shower handles will become impossibly stiff to turn. By understanding the specific mechanics of washers, seats, and packing, you stop guessing at surface strips. You have the diagnostic logic required to master the invisible pressures running through your home.